Welcome back to Akshar Society Foundation classes. I am your chemistry faculty S. Mohan. So in this 8th class under IIT Foundation classes, we have started a chapter atomic structure, and since 3 months almost we are doing the same chapter. Because it's a very lengthy chapter, that's the first thing, and it's a very important in terms of IIT JEE mains and advanced, and most of the chemistry depends on this atomic structure. So that's what we were going slowly and explaining each and every topic. So hope that you are doing means accordingly academically. So hope that you are doing well. I mean, you are understanding what we are doing and everything. So now we came to the end of this chapter. So in the last class we discussed about the spectrums, and today we are going to discuss about the last topic of this chapter, that is Bohr's atomic model. So students, here we discuss about the Bohr's atomic model now as a last topic, but in the atomic structure it's not a last topic. Okay, so you are in 8th class. When you come to the 9th class, again you'll have the continuation of this chapter. It's a very lengthy chapter. Okay, but up to Bohr's model is one part of the atomic structure will be done. Okay students, so once a little I'll revise the whole chapter. No, first I'll do the Dalton's atomic theory today. This is a very small topic. After that, once total synopsis, the total first chapter, will revise for 10-15 minutes. Okay, so that will be easy. No, sure. So students, here Bohr's atomic model. See students, here already we discussed about the Rutherford's atomic model. In the Rutherford atomic model, we also concepts. What are the concepts of Rutherford atomic model we discussed, and at the same time we also discussed about there were some drawbacks, like means what defects in the Rutherford atomic model. So to rectify the defects of the Rutherford atomic model, here Niels Bohr proposed an atomic model based on the Planck's quantum theory. Based on what? Planck's quantum theory. So students, we are doing the last topic, that is synopsis 7. In this, our main topic is Bohr's model of an atom. Okay, so this Bohr proposed an atomic model to rectify the defects of Rutherford atomic model. Okay, why propose atomic model? To rectify the defects of Rutherford atomic model, and based on what? Based on Planck's quantum theory. Important point here, this is based on Planck's quantum theory. Based on Planck's quantum theory, Niels Bohr proposed the atomic model. Okay. Now, what are its postulates? Okay, means what are its important points? In the Rutherford model, just 1 minute. The Rutherford, we discussed we revise Rutherford model. So Rutherford model, what is it is from the gold foil experiment. So it said that atoms are spherical in shape, and atom consists of a small region at the center, which is called as a nucleus, and the nucleus, the total positive charge, and almost all the mass is situated or concentrated in that center region, that's called nucleus, and electrons will be revolving around the nucleus like planets around the sun. This was the concept, right? But here the drawback also we discussed. According to classical laws of physics, any charged particle, if it is moving, it loses, it radiates its energy. Then it will be attracted towards the nucleus, then it come close to the nucleus and it fall in the nucleus, then atom should collapse. If atom collapse, then no matter exists, because matter is made up of a tiny particles called atoms, already we studied. If matter does not exist means what you are watching around you, nothing exists, including you and me also. Alright. So, to rectify that defect, Niels Bohr proposed a model based on the Planck's quantum theory. So, what are its important features? The first point what it states is, electrons revolve around the nucleus in a specified circular path. So, it is a nucleus, and he said that electrons will be revolving around the nucleus in a specified circular paths. Like these paths are there all around the nucleus. So, in this specified circular paths, electrons revolves. Okay, and he gave the name to these paths as orbits or shells. Orbits or shells. Okay, that's the first point. The second point, what he said that electrons revolve around the nucleus. Very good. And it said that as long as, very important point this one, as long as electron revolving in its particular orbit, it neither loses nor gains the energy. Okay. So, there in the Rutherford, this is a main drawback. Okay. So, when a charged particle is revolving around the nucleus, that loses its energy and come closer to the nucleus, then falls in the nucleus, then atom should collapse. But what he said, as long as electron revolves in its particular orbit, its energy is constant. Means what? Neither loses nor gains the energy. So, hence these orbits are called stationary orbits or stationary shells. Why? Because the energy of the electron remains constant. So, this is a point that explains that atoms are stable, right? Next point, what is it, students? Here these orbits are named as like K, L, M, N and so on. These orbits are named as what? K, L, M, N and so on. And he said that every orbit is associated with some definite amount of energy. Every orbit has some definite amount of energy, and the energy of the orbit increases as we move far from the nucleus. Or you can say that as the size of the orbit increases, the energy of the orbit also increases. For example, see here, let you think this is a K shell very close to the nucleus, let its energy is E1, and L shell, let's energy is E2, M shell, let's energy is E3, N shell energy is E4. So, according to according to Niels Bohr, E1 has least energy, then E2, then E3, then E4 and so on. Okay. So, meaning is what? Every orbit is associated with some definite amount of energy, means particular amount of energy, and as we move far from the nucleus, the energy of the orbit increases. Okay. So, this is the second point, right? Then, what is the third point? Third point, what it states is, sometimes electrons may jump from higher energy orbit to the lower energy orbit. For example, let's think here electron is here. Okay, sometimes electrons may jump from higher energy orbit to the lower energy orbit. When electron jumps from higher energy orbit to lower energy orbit, so here the higher energy orbit energy is what? E3. Okay, it's jumping into K shell. What is energy? E1. Okay, so when it jumps from high energy orbit to lower energy orbit, it radiates, means emits the energy. It emits the energy. How much energy it emits? It emits the energy that is the difference between the energies from which orbit to into which orbit it's coming. Okay, so means what? It's jumping from M shell, that is energy is E3, and jumping into the E1 K shell, that is E1. So when it jumps from high energy orbit to the lower energy orbit, it emit out, radiate the energy, and that radiated energy E, okay, is equal to E3 minus E1 in case if it is jumping from third orbit to the first orbit. In case if it jumps from the second orbit to the first orbit, E2 minus E1. Okay. So, only when electron jumps from high energy orbit to the lower energy orbit only it radiates or it emits the energy. Okay. If it is moving only in its original path, in its own orbit, it neither loses nor gains the energy. And similarly, for example, you think if electron is present here, okay, electron is present in the first shell. Think electron is present in the first shell. If we heat the atom, if you provide some energy to the atom, then this electron absorbs that energy and jumps into the higher energy orbit. It jumps into the higher energy orbit. So, into which orbit it jumps? So, here how much energy it's gaining, based on that it jumps into the higher energy orbit. Clear to you? So, when electron absorbs the energy, the electron jumps into the higher energy orbit. And after that, again it comes back to its original state. While coming back, meaning is what? Jumping from higher energy orbit to lower energy orbit, it emits out the energy. Clear? Right. Next, one more point. Next point what he said is the angular momentum of an electron. Angular momentum of an electron. Angular momentum of an electron is given by the formula mvr. What is the formula? mvr, where m is the mass of electron, v is the velocity of electron, and r is the radius of the circular orbit in which that electron is revolving. Alright. So, the angular momentum of an electron, that is mvr, is equal to the multiple integrals of h by 2 pi. Very important formula. So, this is mvr is equal to nh by 2 pi. mvr is what? Angular momentum. Angular momentum of an electron is equal to multiple integrals of h by 2 pi. Okay. So, that is about the Bohr's model. Okay. So, these are the 4 points. What are the 4 points? First one, electron revolves around the nucleus in a specified circular paths which are called as the orbits or shells. And as long as electron in its particular orbit, its energy remains constant. It neither loses energy nor gains energy. Hence, these orbits are called stationary orbits or stationary shells. Right? Then, every orbit is associated with some definite amount of energy. So, hence these are called as the energy levels. What they are called? Energy levels. And here, these are represented with K, L, M, N, and so on. And as we move far from the nucleus, or as the size of the orbit increases, the energy of the orbit also increases. Third one, electrons may jump from lower energy orbit to high energy orbit when it absorbs energy. When electron jumps from high energy orbit to lower energy orbit, it radiates the energy. Okay, how much? That is difference in the energies of those orbits, and that is given by the equation called E2 minus E1 is equal to h nu. Okay, and last and final one is what? The angular momentum of an electron can be calculated by using the formula mvr is equal to nh by 2 pi. So, these are the important features of the Bohr's atomic model. Apart from this one, Bohr did anything? Yes, he also given a formula to find the radius of the orbit, to find the radius, okay, radius of the orbit, okay, till here or till here or till here, okay, till here. So, like this, okay, he gave a formula to determine the radius of the orbit, energy of the electron, so many things he has done. For that, he received the Nobel Prize. He received the Nobel Prize. Okay. So, students, here there are so many equations are there, derivations are there, but these all we are not going to discuss in this class because still you are only in the 8th class. So, here just we are not going to discuss about the derivations and all these things. So, only postulates we are discussing in this class. Okay. So, once if you have a material, open the page number 63. So, you can see that postulates of Bohr's atomic model. The basis of the Bohr's atomic model of an atom is a Planck's quantum theory. Just now I told you that Bohr's quantum theory was based on based on Planck's quantum theory of radiation, right? So, see a circular orbits, electron revolve around the nucleus in the concentric circulars like KLMNOP, KLMNOP, okay, or 1, 2, 3, 4, and etc. Next is the stationary orbit, second point. Each orbit is associated with some definite amount of energy. So, they are called energy levels of stationary orbits, okay, energy levels of stationary orbits. Energy of the orbit. The energy of the orbit increases with increase in the distance from the nucleus. So, as you said, as the distance increases, the energy of the orbit increases. That is, E1 is less than E2 is less than E3 is less than E4 and so on. And condition for the emission or absorption of energy, an electron can move from one orbit to another orbit only when they lose or gain the energy. So, just wanted to do that when electron jumps from high energy orbit to lower energy orbit, they emit out the energy and they form the emission spectra. And when absorbs the energy, they jump from low energy orbit to high energy orbit, and that forms the absorption spectra, which is spectra we are already learned in the previous classes. How much energy is absorbed emitted? So, I have given that E3 minus E1 or E2 minus E1, which is also equal to h nu according to the Planck's theory. Quantization of angular momentums, yeah, electron can revolve only in those angular momentum is multiple integrals of h by 2 pi, so Br is equal to nh by 2 pi. So, that's all students, that's all about the Bohr's atomic model, and here there are some merits already. Just now I told you that the experimental values of the radius and energies in the hydrogen atom of the good agreement with the calculation of the Bohr's atomic model. So, Bohr successfully explained the atomic spectrum of hydrogen spectrum, and so these are the merits of the hydrogen spectrum. Apart from that, so here so many equations were given to calculate the radius of the orbit and energy of an electron and so on. So, these are all we are not going to derive here, just overall some formulas were given in the page number 65. If you have a textbook, you can see the page number 65 here. There are some formulas out there. These formulas are very important, but only calculation purpose you can use it. We are not going to derive in these classes because these derivations you can learn, you can study in the 11th standard, right? Okay, students. So, with this chapter is done. So, here let us see some questions, and then we will discuss the total chapter of this total 7 synopsis once we discuss all these things. Okay. So, Bohr's model can explain the spectrum of any atom or ion having only one electron. The answer is 2. Page number 65, concept based questions. As the number of orbit increases from the nucleus, the difference between the adjacent energy levels, okay, that is increases. According to Bohr's theory, the radius of electron in an orbit, that is not given, but you see here at the top you have the formulas here, but the answer is 4, that is n square by z. Angular momentum of an electron in nth orbit is given by nh by 2 pi, so the answer is third option. When electron jumps from n shell to k shell, n shell to k shell means higher energy to lower energy orbit. So, what happens? Energy is emitted or energy is released. Okay, second is the option. When electron jumps from higher energy orbit to lower energy orbit, what is produced? Emission, because it's emitting. The radius of the nth orbit of hydrogen atom, this is not given, but in the formulas are there, that is Rn square, so the first option. According to Bohr's postulates, which quantity can be taken in discrete values, kinetic energy, angular momentum. So, just want to discuss about the angular momentum, so option is 2. The energy of an electron is infinite distance from the nucleus in Bohr's model is taken as 0. Bohr's atomic theory is given an idea of what? Quantum numbers, shape of the nucleus, stationary states or stationary orbits. Here it is there. Next, for the electron moving in a circular orbit, the hydrogen atom, the force of attraction, nucleus balanced by the forces, I think minus mv square by r, option is 2. Change in the velocity when electron jumps from the k shell to l shell, one of the original velocity, option is 1. Delta E is the maximum when E2 minus E1. That's first option. Energy difference between the two objects, two adjacent atoms is minimum when, see here, the K and L difference is more, less difference, like this difference would be decreases. So, the answer is N and O is the right answer. Bohr's atom can explain the spectrum of all except. So, see here the answer is helium. Why? Because hydrogen, see Bohr's model explains the atomic spectra of any element, any atom or any ion which has only one electron. So, hydrogen is correct, He plus already we discussed. So, one electron, only it has one electron, lithium plus 2, only one electron. Okay. The radius of the orbit of hydrogen is equal to n square s square by 4 pi square m is d square. That is the correct answer. So, first option. Angular momentum of the electron in M shell. M shell means which shell? 1, 2, 3. So, this number is 3. 1, 2, 3. In the place of n, you put 3. So, 3h by 2 pi. The answer is 3h by 2 pi. So, that is the first option. Okay, students. So, with this, we completed the first chapter, that is atomic structure, which is of almost 71 pages chapter. So, we did this one, right? So, now once we revise this chapter for 5 minutes, within 10 minutes, I'll total 71 pages chapter. Briefly, I'll explain you just a minute. Okay, students. So, here atomic structure, total atomic structure, 7 synopsis I am going to discuss. Listen carefully. Alright, what we have studied in this one. First, matter. Matter means anything which has a mass and occupy the space is called as a matter. Right? Matter is classified in 2 ways. One is based on the states and second is based on the composition. Based on the states, solids, liquids and gases. Based on the composition, pure substances and impure substances or mixtures. Pure substances again classified into elements and compounds, okay, which are made up of same type of elements. Mixtures are classified into homogeneous and heterogeneous. Homogeneous are also called as true solutions and heterogeneous are also called as 2 types of them, okay. One are called colloidals and second is called suspensions, okay. This is about the first synopsis, classification, okay. Now, in the second synopsis, what we discussed? In the second synopsis, we discussed that ancient views of an atom. So, atom is any matter is made up of a tiny particle and it is indivisible. So, based on that Dalton's atomic theory we studied. So, the Dalton's atomic theory what we studied, atoms are indivisible, means we cannot break the atom. Atoms of same element will have the similar properties, atoms of different element will have the different properties. So, atoms will combine in small ratio to form the compounds. So, about this we have learnt in the second synopsis, okay. And third synopsis what we discussed is about the atomic number mass, J. Thomson's model and Rutherford model. J. Thomson model disproved that Dalton's atomic theory, okay, means what? Dalton's atomic theory was wrong. Atoms can be divisible, and by his famous discharge tube experiment, he discovered the electrons. And he proposed an atomic model which is called as a Thomson's atomic model or water model of atom, right? But here drawbacks are there. To rectify this drawback, Rutherford conducted one gold foil experiment, okay, or all foil scattering experiment, and he proposed that atom has a nucleus in which protons and neutrons are present and the electrons will be revolving around the nucleus, okay. Then what we discussed about the atomic number, mass number, new concept. Atomic number means what? The number of protons in an atom is called as atomic number. Sum of the protons and neutrons is called as a mass number. So, this we discussed in the next synopsis, right. And then come to the fourth synopsis, we discuss about the nature of light, okay. So, there was first theory that is called as a corpuscle theory, then wave theory were proposed, then we discussed about the electromagnetic theory, wave theory. So, this is a wave theory. The light travels in the form of a wave, and we discussed about the electromagnetic theory also. The lights or electromagnetic radiations, it consists of like, cosmic rays, gamma rays, X-rays, ultraviolet rays, visible spectrum, infrared, microwaves and radios. This all we discussed, right. So, then that only a small region we can see, that is called as a visible spectrum. Then we discussed about the properties of characteristics of the wavelength and frequency and velocity of wave, okay, amplitude, time period. This all we discussed in the fourth synopsis, right. And the fifth synopsis what we discussed in the fifth synopsis about the photoelectric effect, right. The the Planck's quantum theory, black body radiations, this all we discussed okay, in the fifth synopsis. So, in that we discussed mainly about the Planck's quantum theory and we discussed about the photoelectric effect. Okay. So, Planck's quantum theory, this, okay, this we studied in the fifth synopsis, right. And then come to the sixth synopsis, we discussed about the spectrum. Spectrum is what? A series of wavelengths and frequencies, a group of okay, frequencies and wavelength is called as a spectrum. And spectrum types, emission spectrum, absorption spectrum, continuous spectrum, discontinuous spectrum, then line spectrum and band spectrum. These all types of spectrums we discussed in the sixth synopsis. Now, in the seventh synopsis, what we discussed here? Bohr's atomic model. So, Bohr's atomic model we discussed in the seventh synopsis. So, students, here we are completed almost 75% of actual atomic structure what you are going to learn in the 11th and 12th standards, that we are completed 75% of that chapter. So, if you are understood and if you have followed and if you are studying that, then you are really great. So, and I hope you need applause for yourself. Okay. So, claps for yourself. So, very good, keep it up and study well. So, tomorrow means in the next class we are going to start the second chapter. The second chapter is the periodic properties, about the periodic table, elements, how does the following properties will be changes in a period and in a group, and so many new things like atomic radius, ionization energy, electropositivity, electronegativity, and electron gain enthalpy. Okay, so many things, electron affinity, like this, so many things we are going to study in the next synopsis. Okay, so until, take care, bye. With this we stop our class. Okay, bye students.